Hello students, so let's solve few extra questions. We have already solved 24 questions from indices. Let's add few more questions now. Okay, so I'll continue the numbering. After this, I've not categorized as which particular topic it belongs to. Okay, so it's all mixed up. So solve with me. Question number 25. Question, the value of 8 to the power 1 by 3. What is 8 to the power 1 by 3? I can write this as 8 to the power, let me just increase the thickness. Okay. 8 to the power 1 by 3 can be written as cube root of 8. What is cube root of 8 equal to? Cube root of 8 is equal to 2. Yes, it's there in option C. Okay. First we have some basic level questions also. It's all mixed up, easy, difficult, coming from different topics. This was an easy one. Question number 26 now. The value of 8 divided by 27 raised to the power 1 by 3. We have 8 divided by 27 raised to the power 1 by 3. So we have cube root of 8. Cube root of 8 is how much? Cube root of 8 is 2. Cube root of 27. Cube root of 27 is 3. So we get 2 by 3 as the right answer. Okay. We move on to the next question. Question number 27. We have value of a particular thing we have over here. A value of this raised to the power 0 is there. Raised to the power 0. So anything raised to the power 0 is equal to 1. Correct? Raised to power 0 is equal to 1. Simple. Moving further. 28. Okay. Now it's not that straightforward, but not very difficult. Also, we have 3 to the power 3 whole square into 4 square whole cube into 5 cube whole square divided by, we have 3 square whole cube into 4 cube whole square into 5 square whole cube. Correct? Now if you see, everywhere we have base, numerator and denominator, we have base 3, 4 and 5. And if you see the power, we have 3 and 2. Now in laws of indices, I have told you, if we have a to the power m, all to the power n, it is equal to a to the power mn. Or I can also say it is a to the power n into all to the power m. It does not matter. A into b is b into a. So in that case, this 3 to the power 3 into 2, 6, right? This is 3 to the power 6. This is also 3 to the power 6. 4 to the power 6, 4 to the power 6, 5 to the power 6, 5 to the power 6. Everything cancels and what remains is just equal to 1. After everything is over, you are single. Only 1 is remaining. Moving on to question number 29. Which of this is true? So if I just run through it, everything is raised to the power 0. When it is raised to the power 0, we know the answer is 1. Anything raised to the power 0 is equal to 1. That means your left hand side should be equal to right hand side, which is there in option C. Here raised to the power 0, here raised to the power 0. Option C is the right answer. Option A, that says 2 to the power 0 is greater than, it cannot be, then it is. Option B, they say 2 to the power 0 is less than 1 by 2 to the power 0, that also cannot be. So 29 is over. 30, again true option. Fine. We will have to find out the true option. First option is there, x to the power 2 by 3 equal to cube root of x square. Now x to the power 2 by 3, can I write x to the power 2 by 3 equal to x to the power 2. 2 I am writing all to the power 1 by 3. I can write all to the power 1 by 3. Now all to the power 1 by 3, that can be written as cube root of x square, which is there in option A. Option A is the right answer. Further, question number 31. Value of 4 divided by 32 raised to the power 1 by 5. So we have 4 divided by 32 raised to the power 1 by 5. What is the fifth root of 32? Raised to the power 1 by 5 is nothing but fifth root of 32. What is the fifth root of 32? That is equal to 2. 4 divided by 2, what is the answer? Answer is equal to 2. Done. 31 is done. Further, value of y to the power a minus b, let me write it down, y to the power a minus b, y to the power b minus c, y to the power c minus a, y to the power minus a minus b. What does laws of indices say? It says that when base is same, powers can be added. Correct. Now your base is same, everything is 5 to the power. So we'll take 5 to the power a minus b, then we have plus b minus c, plus c minus a, then we have minus a minus b. Basically everything I've written in the powers, base is written only once. Now I'll get my sword just to cancel out. We have a positive, we have a negative, one cancelled, b positive, b negative cancelled, c positive, c negative cancelled. What remains? Y to the power minus a minus b. This is all that remains. So when we have both minus a and minus b, what we can do is take minus sign outside, equal to y minus sign outside a plus b. Further, we can write when we have minus powers, I have told you when we have minus powers in the numerator, we can take it to the denominator. We get 1 divided by y to the power a plus b. Do we have that in the option? 1 divided by y to the power a plus b. Option D is the right answer. Moving on further, question number 33. 8 divided by 27 raised to the power minus 1 by 3. Okay, we'll write down the question. 8 divided by 27 raised to the power minus 1 by 3. Then we have 32 divided by 243 raised to the power minus 1 by 5. We have negative powers. So what should we do when you have negative powers? I've told this before. I've told this in the very previous question also, negative powers that I've just solved. Correct. So when you have negative powers, that should be taken to the denominator, I said. If you have negative powers in numerator, that should be taken to the denominator. What should you do if you have negative powers in the denominator? You should take that to the numerator. Now we have all to the power, correct? This is all to the power. We'll take it to the dark. Okay. This is all to the power. It's coming in yellow, correct? 8 divided by 27, all to the power minus 1 by 3. So what we'll do is we'll just take reciprocal and convert them to positive powers. So we have 27 divided by 8. Remember, don't take reciprocal of the powers. This still becomes 1 by 3. Only minus is gone off. Then we have 243 by 32 raised to the power 1 by 5. 1 by 3 means cube root of 27 is 3. Cube root of 8 is 2 into fifth root of 243. Fifth root of 243 is 3. Correct? 3 into 3 into 3 into 3 into 3. 3 into 3 is 9. 9 into 3 is 27. 27 into 3 is 81. 81 into 3 is 243. As you solve more and more questions, you get comfortable with this. Divided by fifth root of 32. Fifth root of 32 is again 2. So we have 3 into 3, 9. 2 into 2, 4. 9 divided by 4. 9 divided by 4 is there in the option. Option A is the right answer. Next, question number 34. The value of x to the power a divided by x to the power b, then we have a plus b. Okay, I'll not write the question this time. Okay, we have solved enough questions. So what we'll do is this time I will directly simplify and write. You will agree with me. First I'll go a little slow. X to the power a minus b. Can I write it this way? Correct. X to the power a divided by x to the power b can be written as x to the power a minus b. Remaining a plus b I am writing as it is. This a plus b I am writing as it is. This I will highlight now. This is there, no? This I have written over here, a minus b. Fine. We'll continue now. X to the power, solve with me, b minus c, then we have b plus c, then we have x to the power c minus a, c plus a. Correct. With that we have everything to the power x I think we can simplify further before that. So we have, now what I'm highlighting, you see, we have a minus b, a plus b. And this is coming from identity, correct? What do we know about this particular identity? I'm writing that down. We know that a minus b, a plus b is equal to a square minus b square. It is given in identities. So I'll simplify it right now. I have x to the power a minus b, a plus b is there. I get a square minus b square. Continue. X to the power b square minus c square. Continue. X to the power c square minus a square. Now base is same, powers can be added. X to the power a square minus b square plus b square minus c square plus c square minus a square. So now we get some cancellation. Let's see what cancels. A square cancels with a square, b square cancels with b square, c square cancels with c square. So we get x to the power 0, which is equal to 1. Only 1 remains. Option A is the right answer. When you see the question like this only, you will understand it once you have solved a couple of times. Okay, something like this is there. You know the answer is right away 1. Fine. Next question, question number 35. The value of, we have 3 to the power n plus 1 plus 3 to the power n divided by 3 to the power n plus 3 minus 3 to the power n minus 1. Okay, this is the question. Just for understanding purpose, if I do it directly, you may get confused. We will expand this a little bit. Okay, right now it is in the power of 3 to the power a plus b is there. So I will rewrite this as 3 to the power n into 3 to the power 1 plus 3 to the power n. Sure you agree? Correct. When you have x to the power a, x to the power divided by, x to the power a into x to the power b is x to the power a plus b. So now from that plus a plus b, I have rewritten it as x to the power a into x to the power b divided by, same thing we'll do over here also, 3 to the power n, 3 to the power 3, okay, minus 3 to the power n divided by, or you can write 3 to the power minus 1 here, not divided by 3 to the power minus 1. You'll write it this way. The objective of this is, I can take the common one outside, factorizing it. Correct. Now if I simplify this, what is common? Let me highlight that, or let me just circle it. 3 to the power n is common. So I'll take it outside the bracket. We have 3 to the power n common. What remains inside 3 to the power 1 is just 3. That's it, nothing is there, so plus 1 divided by, in the denominator what is common? Use a different color. You go for green. Again 3 to the power n is common. So I'll take that outside now. I get 3 to the power n. We have 3 to the power 3 minus 3 to the power minus 1. Correct. So with that I think 3 to the power n cancels completely. This goes off. 3 plus 1 is equal to 4. This is 4 divided by 3 to the power 3. 3 to the power 3 is how much? 3 to the power 3 is 27 minus we have 3 to the power minus 1. 3 to the power minus 1 is 1 by 3. Correct, right? Now simplifying further, I get 4 divided by LCM in the denominator, common denominator is 3. 27 into 3, how much is that? 81. So we have 81 minus just 1, no? 81 minus 1. Perfect. Now this 3 goes to the numerator, equal to 4 into 3. 12 divided by 80. I get 12 divided by 80. How much is 12 divided by 80? Can I simplify directly? Divided by 80 when I do, I get decimals 0.15. And which one is giving us the right answer? 1 divided by 5 is 0.2. 1 divided by 6 is 0.16. 1 divided by 4 is 0.25. So 3s are 12. So okay. So answer is none of this. Question number 35. Answer is none of this. 12 divided by 80 is the right answer. If I have to simplify this further, I get 3 goes how many times? 3 does not go, is it? In 80, 80 does not go. No, don't take 3. So we can take 6 at the most. And here we can take 40. Half I have done. Further, this goes 2 times. This goes 20. So you get 3 divided by 20 as the final answer. 35 done. We'll move on to the next question. Question number 36. Okay. 2 to the power x minus 2 to the power x minus 1 is equal to 4. So I have 2 to the power x minus 2 to the power x minus 1 is equal to 4. Then we have to find the value of x squared. What we'll do first now is we will take the common outside just like how we did in the previous question. So we get 2 to the power x minus 2 to the power x into 2 to the power minus 1 is equal to 4. Correct. Now we have 2 to the power x common. We'll take it outside. 2 to the power x common. We have 1 minus 2 to the power minus 1. I can write 1 divided by 2 equal to 4. Correct. Fine. So from 1, if I reduce 1 by 2, I get 1 by 2. So we have 2 to the power x, no? We have 2 to the power x 2 to the power x into 1 minus 1 by 2 is 1 by 2 equal to 4. Cross multiply. You get 2 to the power x is equal to, this 2 goes to the other side which is there in the denominator. So 4 into 2. 4 into 2 is equal to 8. Correct. Now what we'll do is 8 can be written as 2 to the power something. So we have 2 to the power x is equal to 8 can be written as 2 to the power 3. Correct. So when base is same, I've clearly told you when base is same, powers have to be equal. Implies, I'll continue on the right side over here, x is equal to 3. But they're not asked for x, they've asked for x square. X square is 3 square, x square is equal to 9. X square is equal to 9. We have it in option D. Fine, that's 36 for you. Very similar to what we did in the previous one. We took the common outside and then simplified. Also here we have used the result when base is same, powers have to be equal. If you feel I'm going a little fast, I am actually, because these are extra questions. I want you to build up that speed. Definitely you can pause and watch. Maybe you can pause and write, or you can maybe slow down and also watch. Otherwise you'll have to watch it again. Fine, that's 36. 37 now. Find the value of x if x into x to the power 1 by 3 equal to x to the power 1 by 3 all to the power x. Let me rewrite the question. We have x to the power 1 by 3 equal to x to the power 1 by 3 all to the power x. Let me just simplify this now. So we have x to the power. We can write this as 1 plus 1 by 3. Why? We have x to the power 1 over here, even though it is not really there, but it is there. Correct? When it is not mentioned, it is raised to the power 1. So we have 1 plus 1 by 3. When base is same, powers can be added. Equal to. And when we have x to the power m all to the power n, we get x to the power mn. That is, I multiply x inside, so I get x by 3. Now if you see over here, the base is same. We have x over here, base is same. There is equal to sign in the middle, and we can write the powers also to be equal. The powers are equal, so we get 1 plus 1 by 3 equal to x by 3. From here it is normal simplification. We'll take the LCM on the left hand side. We get 3 as the common denominator. Cross multiply 3 plus 1, which I will write in the next step as 4. So we get 4 by 3 equal to x by 3. 3 cancelling on both sides implies x is equal to 4. Do we have that in the option? Yes, we do. Option B is the right answer. Fine. We'll move to the next question now. Question number 38. X is given. x is equal to, let me rewrite that, x is equal to 3 to the power 1 by 3 plus 3 to the power minus 1 by 3. We have to find the value of, that I'll write in this side, 3x cube minus 9x. This is my requirement of the question. Now something very similar I've already solved. In the main exercise I have solved it, where we had p minus p to the power minus 1 by 3. Something like that was there, or in fact I think it was plus. But something very similar was there. And there they had given you the clue that we have to use a particular identity. Here nothing is told. So here what we can do is, if you see here, the requirement as x cube, and we are starting from this point x. What is the only way we can get x to x cube? I need to cube both sides. And I've already told you, whatever you do on one side of the equation, you need to do the same thing on the other side of the equation. So let me try doing this. Cube both sides. Fine. Just left hand side straightforward, we get x cube. Right hand side I get, in this step I'm just writing the given question raised to the power 3. Now when we have a plus b whole cube, we again have to use identity. We know that. What do we know? We have a plus b whole cube is equal to a cube plus b cube plus 3 times ab into a plus b. Now we'll start substituting the values. What is a for us? I'll identify that also. We'll use a different color. We'll go for green. Okay. So in the given equation, we have this one as a for me, and this one, this entire part as b. We'll do this substitution slowly now so that we do not go wrong. Left hand side as it is. So I have x cube equal to, correct? We have to expand now. We have a cube plus b cube. A is how much? 3. 3 by 3 to the power 1 by 3. This entire thing is a whole cube plus, what is b? 3 to the power minus 1 by 3 whole cube. A cube is done, b cube is done, plus 3 times. A we need 3 to the power 1 by 3. B we need 3 to the power minus 1 by 3. Then we have a plus b. So a is 3 to the power 1 by 3 plus 3 to the power minus 1 by 3. In the next step, we'll just simplify. I see that there is raised to the power 1 by 3 and also to the power 3. We can easily cancel that off. Okay. See, I'll cancel this 3. I'm cancelling another 3 and another 3. So cancel few things. Let me rewrite what is remaining. Left hand side, nothing to be done for now. We have x cube. All that remains in the first one is 3. To the power 1 is 3. So 3 only, plus we have 3 to the power 1 by, no, 3 to the power minus 1 that is remaining. No, 3 to the power minus 1 is remaining. So I can put it as 1 by 3. 3 to the power minus 1 is 1 by 3 plus we have common base. We have common base and we can add the powers. We have 3 to the power 1 plus 1 minus 1. This is all that is remaining. Then we have 3 to the power 1 by 3 plus 3 to the power minus 1 by 3. Let me simplify further. We get x cube equal to 3 plus 1 by 3 plus, now if you see here, plus 1 minus 1 cancels, plus 1 minus 1 cancels. What again remains is only 3. Now what to do with this part? This is the part which I was not able to solve so far. What to do with this part? Remember what we did with that, p to the power 1 by 3 plus p to the power minus 1 by 3. Now this part is same. Okay, I'll change the color now. Go to red. This part is same as what was there in the original question. I'll take it over here. Okay, this will be too much scribbling. What is there in the original question? What is that equal to? That is equal to x. So now I'll replace this part to be equal to x. Now if you see the requirement of the question, it is very close. 3x cube I need minus 9x. So I'll get that 3x to the other side. I get x cube plus 3x equal to 3 plus 1 by 3. This is all that is remaining. Now, sorry, it should be minus, no? It should be x cube minus here. Small correction. When you take from one side to another, sign changes. So we have x cube minus 3x is equal to 3 plus 1 by 3. Simplifying further, we get x cube minus 3x is equal to, common denominator is 3. 3 into 3 is 9. 9 plus 1 is 10. We'll continue over here only. Okay, so the small part is remaining. Just divide it. Just divide it over here. Okay, small part is remaining. So cross multiply now, you get 3 into x cube. Then we have 3 into minus 3x minus 9x equal to 10, which was the exact requirement of the question. So the answer is equal to 10. Correct. So something very similar was done. Please refer to that particular solution. There also we used a plus b whole cube, cubing both the sides. But in that particular question, they had given you a hint as to which identity has to be used. Here it has to come naturally. Fine. Solve this couple of more times, you'll get used to it. More questions are there, something like this. Okay, we'll move on to the next question now. Question number 39. P to the power x equal to q. Q to the power y equal to r, and r to the power z is equal to p to the power 6. Then the value of x, y, z will be, to find the value of x, y, z. Fine. So what we'll do over here, we will write the given question neatly first. Something very similar was done in the main exercise, but small difference is still there. Okay, because there it was little more simple, I feel. Now we are taking it little complicated one. So 3 values are given. Now if you see everything, here we have raised to the power nothing, here we have raised to the power nothing, but here we have something, no? So we have the value of q equal to, we have the value of r equal to, but we don't have the value of p equal to given directly. So first I will solve for that. Now if I continue with this only, r to the power z is equal to p to the power 6. If I want the value of p, r to the power z raised to the power 1 by 6, and p is equal to r to the power z by 6. So I got the value of p. So I got the value of q. I add the value of r. Now I got the value of p. Why did I do this? So that I can merge them. Now let me go back to blue. I'll take the anyone I can take p to the power x equal to q. I'll take the very first one, p to the power x equal to q. What is p equal to? P is equal to r to the power z by 6. See what I'm highlighting? This p is there, no? Only that value is substituted over here. Yellow. And remaining I'm writing as it is. X as it is, then I write z. Oh, then I write q. Okay. Now I'll join this, okay? So we have r to the power z x by 6 equal to q. Now what is r equal to? R is equal to q to the power y. R is equal to q to the power y. In place of r I have written this. All to the power x and z I had already written, divided by 6 also I have written, equal to q. Now if you see, base is same, but I'll show one more step. We have q to the power x, y, z divided by 6 equal to q to the power 1. So now I got base same. Okay. So I get implies x, y, z divided by 6 equal to 1. Implies further x, y, z cross multiply, answer is equal to 6. Which is there in option D. Done. 39 is also done now. We'll move further. Question number 40. We have to simplify this. X to the power m plus n. Now we'll need to speed up, right? So now I'm not writing the question entirely again. We have x to the power something into x to the power. So when we have product with same base, we can add directly plus 4m minus 9n. Directly I'm writing. Divided by, again we have x to the power only. So we have minus 6m minus 6n, but make sure you put this bracket, otherwise you'll go wrong. Because minus entire thing what is there in the denominator. Now further simplifying this. In this step all that I'm doing is I'm opening the bracket. Maybe in the next problem I'll write the minus directly by multiplying. Minus of minus will become plus 6n. Okay. So now if you see, we have m, we have 4m, m is there, 4m is there. That becomes 5m minus 6m, x to the power minus m is remaining. Now we'll come to n. When it comes to n, this is x plus 3n, no? Yeah. I think I made a mistake. Okay, x plus 3n. So 3n is there. 3n, 6n minus 9n. So n nothing remains. See here we have 3n. I'm highlighting 1 minute. Okay. We have 3n, 9n, 6n. This will be together 0. Nothing else is remaining. When it comes to m, only minus m will remain. And that becomes my answer. Okay. That itself is the right answer, x to the power minus m, which is there in option B. Option B is the right answer. 41. Very similar problem is there. Correct? And answer is 1. But we'll still solve it so that we get the practice. We have done it once. Lengthy problem. Ultimately, everything will cancel. No problem, we'll do it same to same. Letters are changing. So we'll do it. 1 divided by 1 plus z to the power a minus b is there, that I can write it as z to the power b plus z to the power a divided by z to the power c. I hope you know what I am doing. I have expanded this z to the power a minus b as z to the power a divided by z to the power b and so on. I'll continue doing this plus 1 divided by 1 plus z to the power b divided by z to the power c plus z to the power b by z to the power a plus 1 divided by 1 plus z to the power c by z to the power a. I've completed it. What is the next step? Next step, we have LCM in the denominator's denominator. We have 1 divided by common denominator z to the power b plus c. Correct? That's the LCM. Okay. We have z to the power, we'll change the color a little bit. We have this z to the power b, z to the power c, so we have to multiply, so we get z to the power b plus c, and the other one denominator is equal to 1. Okay, now cross multiply for the LCM. We have z to the power b plus c plus z to the power a is there as it is. Now we have to add plus c. We are cross multiplying with the other denominator plus z to the power a is there. Okay, and now we have to multiply it with plus b. Correct? Now this is the way we do LCM. Plus 1 divided by common denominator here is z to the power c plus a. So z to the power c plus a plus z to the power b plus a plus z to the power, what was that? It is b, no? Z to the power b. Yeah, so z to the power b plus c. This is also complete. Plus 1 divided by whole divided by z to the power a plus b. Cross multiply a plus b plus z to the power c plus b plus z to the power c plus a. What is the next step? Next step is where you take it to the numerator. We get z to the power b plus c whole divided by z to the power b plus c plus z to the power a plus c plus z to the power a plus b. Just writing the simplified version now. z to the power c plus a all divided by z to the power c plus a plus z to the power b plus a plus 1 minute earlier plus z to the power b plus c plus we get 1 divided by z to the power not 1 divided by z to the power a plus b in the numerator. Okay, reciprocal you have to take. We get z to the power a plus b plus z to the power c plus b plus z to the power a plus c. Now if you see the denominator, it is same throughout, and if you take the numerator, you get the exact same thing as what we have in the denominator. What I'm saying here is, see here, if you see denominator is same, b plus c is there, b plus c somewhere is there, b plus c, and we have b plus c. So that way the denominator is same. When the denominator is same, we can add the numerator, and after adding the numerator, you get exactly same numerator and denominator. We will cancel off everything and tick the answer as 1. Very similar question is there where we have solved it in full. Here I'm stopping it over here because in the examination also you should know where to stop, because at some point we have to stop and get the answer as 1. I've done almost the solution. Last part I'm skipping because I have told you denominator is same, numerator is same, everything cancels off and you get the answer as 1. That's question number 41. We'll move further. Question number 42. We have square root of 3 divided by 9 raised to the power 5 by 2. Then we have 9 divided by 3 square root of 3 raised to the power 7 by 2 and into 9. Now the bases that we have all are perfect numbers of 3, or we can write them as 3 to the power something. So we'll do that in the first step, then we'll see how we can simplify. Why is this important? Because once the base is same, we can add the powers, reduce the powers and so on depending on multiplication and division. So 3 to the power 1 by 2. Correct, square root of 3 is 3 to the power 1 by 2 raised to the power 5 by 2 as it is, divided by 9 is there, so 3 square raised to the power 5 by 2. 5 by 2 from where is it coming? It's coming from here. That is common for both. Into we have 9. 9 is 3 square raised to the power 7 by 2 as it is, divided by 3 into 3 to the power 1 by 2 whole to the power 7 by 2 into 3 square. From where 3 square? This 9 is there, no? 3 square. So now I've written everything as power 3. First step is to cancel off as much as possible. Let's see, we can cancel this 2 with this 2. Numerator and denominator only cancelling. Don't cancel numerator or denominator. Be careful. Okay, this is cancelled. Remaining we will write what is there. Let's see what's remaining. So equal to 3 to the power 5 is remaining. No, 5 by 2 is remaining. 5 by 2 is remaining. Then we have 3 to the power 7 that is remaining. Then we have 3 to the power 2 that is remaining. That's it in the numerator. Divided by 3 to the power 5. This is the. Next we have 3 to the power 1 by 2. 1 by 2 is there here. 3 to the power 1 is there. No, invisible 1. Now I'm writing that 1. So 1 plus 1 by 2 is 3 by 2. So I have 3 to the power 3 by 2 all to the power 7 by 2. Still not open to 7 by 2. We'll do it in the next step. So then remaining, as of now, I'm still writing as 3 to the power only, 3 to the power 5 by 2, 3 to the power 7, 3 to the power 2, all divided by 3 to the power 5, 3 to the power 7 into 3. 7 into 3 is 21 divided by 2 into 2 is equal to 4. Okay. Now everything we have base 3. Further I can write 3 to the power big 3. I'm writing 5 by 2 plus 7 plus 2. Now denominator what is there? We have to take it as minus 5. Correct? X to the power m divided by x to the power n is x to the power m minus n. Minus 21 by 4. Taken all right? Yes. Now we'll simplify. To simplify, we have common denominator in the powers which is equal to 4. We have 5 by 4. No, this is 5 by 4. Make the correction. Everywhere I've written 5 by 2. No, it's 5 by 4. Okay. 5 by 4. Good, I saw that. Okay. Make sure it's corrected. 5 by 4. Okay. We'll continue now. Common denominator is 4. So we have 5 plus 7 into 4, 28. Why 7 into 4? 7 is here. Denominator is 1. So cross multiply with 4. Plus 2 into 4 is 8. Minus 20. Minus 21. Why minus 20? This minus 5 was there, should be multiplied with the common denominator, that is 4. Using calculator now, 5 plus 28 plus 8 minus 20 minus 21. Oh, it's 0. So we have 3 to the power 0 divided by 4 is 0, which is equal to 1. 1 is the right answer, which is there in option A. That's question number 42. What did we do over here? All that we did was we expressed everything in terms of 3 to the power something, and ultimately simplified it to get the answer. Okay. We'll move further now. Question number 43. Few more questions left. Okay. Just now we solved something very similar. So we'll do this quickly. So we have x equal to y to the power n, y equal to z to the power b, and z equal to x to the power c. A, b, c should be brought together. In the other problem, we didn't have the value of all of these x, y, and z, and then we had to convert a little bit. Remember, it was, I think, p to the power z by 6. Something we did just a few problems back. Where was that? Here, right? Yes. Very similar to this question, question number 39. But we made some changes because here q was there, r was there, but p was not there, so we have to write it that way. But in this problem, I think it is quite straightforward. Okay, so we can start from anywhere. I'll start from x only. So x is equal to y to the power a, and in place of y I'll replace x is equal to y is z to the power b, no, all to the power a, this part. What is y equal to z to the power b? From where I got this part. Okay, further what is z equal to? X is equal to z is there. What is z equal to? X to the power c, all to the power b, all to the power a. So further we have x to the power 1. If it is invisible, it is 1. So we have x to the power abc, implies base is same. ABC is equal to 1. ABC is equal to 1, which is there in option B. Done. Question 44. We have to solve this 2 to the power m plus 1, 3 to the power 2m minus n, and there is something missing over here. Okay, so this is plus 3. Please correct the question. This is plus 3. Okay, but in the material that you're getting, the physical copies, it is already corrected. So I'm correcting it over here. Then we have 5 to the power n plus m plus 4. 6 to the power 2n plus m, all divided by 6 to the power 2m plus n, 10 to the power n plus 1, 15 to the power m plus 3. Okay, so all this is there. So what we'll do is we'll try to simplify this. We have 2 to the power, 3 to the power, 5 to the power. We cannot simplify these numbers further. 2, 3 and 5 are prime numbers. But what we can do is 6. So if you see over here, I'm highlighting this. 6 can be written as 2 into 3, right? Okay, so we get lesser number of numbers because our base should be 2, 3 or 5. These are prime numbers. So when we get base this, then powers can be added or subtracted depending on whether they are in the numerator or denominator. So this can be further written as 2 to the power 2m, so 2n, no? 2n plus m into 3 to the power 2n plus m. So this way we will expand. So which are the numbers will expand? 6 will expand, 10 we will expand, and 15 also will expand. Now I'll do the solution directly. Okay, there only we will do the expansion. So we have 2 to the power m plus 1 into 3 to the power 2m minus n plus 3. Then we have 5 to the power n plus m plus 4. Then we have 6, so that I'll expand as 2 to the power 2n plus m and 3 to the power 2n plus m. Expansion is complete. All divided by 6 to the power. Now again I will divide it as 2 to the power 2m plus n, 3 to the power 2m plus n. Correct, 6 is divided as 2 into 3. Next we have 10 to the power. So we have 2 to the power n plus 1 and 5 to the power n plus 1. 5 2s are 10. 15 can be expanded. 5 into 3. So we have 3 to the power m plus 3 and 5 to the power m plus 3. Expansion is complete. Now we have only 3 bases, 2, 5 and 3. So now we'll get all together. So 2 to the power. Okay. I will keep highlighting. So 2 to the power, this part first, wherever it is there I'm highlighting. Okay, 2 to the power m plus 1. Where else we have 2? Over here. Oh, color. Highlighting. 2 to the power 2n plus m. So we have plus 2n plus m. This much is complete. Next we have 2 to the power we have again. So we have it in the denominator, so it becomes minus 2m minus n. Though it is plus over here, it is in the denominator, so we take it to the numerator. Like I told you in the previous problem, when we have in the denominator, when you take it to the numerator, it becomes minus. The common one, minus sign is outside, so minus should be multiplied with both. Minus here, 2 places minus. Fine, I hope that is clear. With that we can proceed. One more 2 is there, no? 2 to the power n plus 1. But when we write, it will be minus n minus 1. So 2 power, everything is done. Next we'll go to 3 power. 3 power, I'll write it in the next line, okay, because this will not fit there. Anyways, remember it is multiplication, this into multiplication. 3 to the power, we'll keep a different color this time. We'll keep yellow. 3 to the power, this one, first one, this one. So we have 3 to the power 2m minus n plus 3. This plus 2n plus m. Denominator we have this minus 2m minus n. Okay, and last one this minus m minus 3. So 3 to the power is also complete. Now we'll go to 5 to the power. 5 to the power, this time I'm not highlighting all the remaining ones. So we have 5 to the power n plus m plus 4 minus n minus 1 and minus m minus 3. So 5 to the power is also done. Now we'll try to simplify further. We'll try to simplify the powers. In 2 to the power we have plus m, 2m minus 2m cancels, plus 1 minus 1 cancels, my plus 2n minus 2n cancels. What remains is 2 to the power 0, remember. Now welcome to 3 to the power. 3 to the power we have plus 3 minus 3 cancels, 2m is there, 1m, 2m, no, 2m and minus 2m cancels, 2m and minus 2m cancels, m and m cancels, 2 minus n and 1 positive n also cancels. We have 3 to the power 0. And 5 के लिए we have minus 1 minus 3 is minus 4, plus 4 cancels, plus n minus n cancels, m and minus m cancels. So what remains finally, like in most other problems, the final answer is 2 to the power 0, 3 to the power 0, 5 to the power 0. Answer is equal to 1, which is there in option C. See, when we have answer as when you get such questions, what I have told you before also, what we should try to do is, but try to simplify, okay, but then sometimes we can even take a chance. Most of the time when you have numerator and denominator, it cancels. Don't do that in the examination, but try to do it quickly, okay. When you are close, when you know it's getting cancelled, try to do it fast and solve it, because the time that is allowed for each question is very, very less. Fine. So that's question number 24. We'll move on to the next question. Question number 25. 25th question, 45. Question number 45. 25 is over here. 25 to the power 150 equal to 25x to the power 50. Now base is not same. Power is not same. Base is not same. Power is not same. We cannot simplify further right away. but I know 50 and 150 is there. So if 50 and 150 is there, I know that I can write this as 25 into 5 to the power 50 into 3 equal to 25x to the power 50. Correct, no? So now what I'll do is that 3 is there, no? That I'll bring it inside. So I get 25 to the power 3 whole to the power 50 is equal to 25x to the power 50. This makes sense to you, no? Correct, because I brought 3 inside. Now if I see the powers are same, this power are equal, implies base also should be equal, implies 25 cube, 25 into 25, 25 into 25 into 25, we get 15625 is equal to 25x. What do we need? We need the value of x, correct? So we'll divide by 25 now. We get 625. So x is equal to 625. X is equal to 625. How to simplify further? It is given as x to the power something. No, correct? 5 to the power something. So we have 625 can be written as 5 to the power 5 square is 25. 5 cube is 125. 5 to the power 4. 5 to the power 4 is equal to x. 5 to the power 4 is equal to x, which is there in the option. Option B is the right answer. So what did we do? Little different. Base was not same, power was not same. So we tried to get at least one same. In this case, we tried to get powers same. So that we can always say when powers are same, base is also equal. That's 45. 46. 46. Something similar we have done, but we'll solve this. We have y to the power a is there, b is there, we'll write it together, a minus b. Then remaining as it is. Into y to the power b minus c will write, remaining I'll write as it is. Then we have c, no? Y to the power c minus a, remaining will write as it is. Now what do we know about this? Like we have a minus b into a square plus ab plus b square. What is this equal to? We have a cube minus b cube is equal to a minus b. This is a square plus ab plus b square. Correct. So using this particular identity, we can write all of them using this identity only. So we get y to the power a cube minus b cube. Then we have y to the power, further going to the next one, this part, okay, y to the power b cube minus c cube, and we have y to the power c cube minus a cube. Base is same, powers can be added, a cube minus b cube plus b cube minus c cube plus c cube minus a cube. So we have cancelling everything. A, B, C, all of them cancelling, we get y to the power 0, which is equal to 1, which is there in option C. Clear? Okay, we have done this before also, I guess. I'm not very sure. Okay, anyways, I've solved it using a cube minus b cube identity. We'll move on to the next question. So we have 3 terms to be equal. First term, second term, third term. I have taught you a method. When 3 terms are equal, we use K method. So this is K method problem. So what do we do when 3 terms are equal? We write each of them. Oh, we have power ka power. Okay, be careful. B equal to K. We write them to be equal to K. Implies, now individually write them to be equal to K. 2 to the power x square is equal to K. Correct. Now what do we do? How do we solve this further? Implies 2 is equal to K to the power. Now x square, when it comes to the other side, you get 1 by x square. Correct. Fine. Next we have 3 to the power y to the power 2 equal to K. Implies, what did I write? Z to the power, is it? It is 3 to the power, no? the small change over here. 3 to the power. 3 to the power y to the power 2 equal to k, which means 3 is equal to k to the power 1 by y square. When powers move from one side to another, you need to take a reciprocal of that. 12 to the power z square equal to k implies 12 is equal to k to the power 1 by z square. So this much we have written. Now what do we need to do? We need to see the relationship. So here we have equation 1, equation 2, equation 3. Correct? So we have 2, 3 and 12. What is the connection between 2, 3 and 12? We know that 2 into 3 is 6. But what if I write 2 square? 2 square is 4. 2 square into 3. 4 into 3 is 12 equal to 12. Correct? So basically I'm saying first equation square into second equation is equal to third equation. Now I'll substitute the values. 2 square is how much? K to the power 1 by x square whole square. Because we have first equation square into k to the power 1 by y square is equal to k to the power 1 by z square. Okay, this is what we get. So now we have base same. When base is same, powers can be added. So we have k to the power, now we'll show one more step, k to the power 2 by x square, because we have to open the bracket, 2 by x square plus 1 by y square equal to k to the power 1 by z square. Do we have this somewhere similar? Ignoring k. So base is same, so powers can be same. 2 by x square equal to 1 by plus, 2 by x square plus it is 2 by x square plus 1 by y square is equal to 1 by z square. Yes, let us just see the letters variables properly because k is removed. So do we have this 2? Where do we have 2 in option C? It is there. Let me just check. Okay, that looks like the right answer. Option C is the right answer. Fine, that's question number 47. So in this video, I'll stop it over here. Okay, question number 47. So these many questions are enough, I feel, from just one particular unit. We had solved 24 in the beginning, and now we have solved another 23 questions or something. Correct? Totally we have reached 47. Should be enough. I've tried to cover almost all different types of questions. Questions are picked from institute material, past examination questions, and different places. So practice these many questions enough number of times. You should be able to crack the questions coming from this particular unit. That's it for now. We'll see you in the next video. Thank you.